Hello and welcome to my channel. This is another video on my series thinking about creative startups. Today I'm thinking about continuous integration and continuous delivery, which is often expressed as your pipeline. And that does sound a bit jargony, but I'll start off with the problem that we're looking to solve. So let's say you're a small creative startup and you have someone who is producing something for you and they're like, oh yeah, it works on my machine. And then you get the product somewhere else and it doesn't work. It fails in front of a client or potential client, even worse. It fails to work when your customers are there. You don't want that. You don't want the it works on my machine problem. Another problem you might get is, oh, show me the latest version. Right, I've got to stop what I'm doing. I've got to build the product. I've got to run over to you with a laptop or post something somewhere. And then you also get the it works on my machine problem, and it doesn't work when you send it to the other person. So that's a very common one. You might also get, so let's say you've got 3 people working on your product and they all have different types of computers, different graphics cards, different plugins installed, different versions of software they're using to build things, and they're getting different outcomes. It's actually very hard to reproducibly build identical software. It worked last week, so something's gone in, some change has been made, and the product has stopped working, and nobody quite knows when it broke, because maybe it is still working on one person's machine. So yeah, it's like the temporal axis of things stopping working. Where did that change come from? No one asked you to build that. Why is that in the product? So this is a failure of process, but there are ways I'm going to talk about to solve for this. But yeah, stuff just popping up in the product that we don't remember specifying. We don't remember a ticket for it. All sorts of problems. Right, this works. Don't change a thing. Now that doesn't sound like a problem, but it is, because you're imposing a change freeze upon people. So let's go through and characterize some of these issues. So it works on my machine. You could look at this as like blessed computer syndrome, like a magic computer where it works. It means that the product is unreproducible. The product is localized to somewhere, and that's a real business risk. I'm sure you can see that if it's only working on one machine, it's a business risk. It worked last week. Well, that's what we call a breaking change. So something has happened, has broken something. So you have an unstable product. You don't want an unstable product. You want something that's reliable. Where did that change come from? Or show me the latest version. Now, these are quite closely related. This is down to a lack of transparency. This is down to, let's say, the business side of the organization being unable to see the latest version of the product at any time, being unable to see, right, what changes have been made from the technical side, or to be able to, actually go through and use the product rather than just looking at a board for seeing what's going on. Okay, this works. Don't change the thing. Well, that's a change freeze, which is a terrible waste of time. So if you've got engineers sat around twiddling their thumbs, that's a huge, huge, huge problem. Now, there are ways around this without using the deployment pipeline approach, CI/CD, I'm going to talk about momentarily. Yes, you can take zip files of working versions and back them up on a server somewhere. You can pass around versions of your products. You can do a lot of stuff, but it all requires manual operations and it's all a little brittle. What we want is a solution that's as automated as possible. So in one of my previous videos, I talked about source control management, source control for creative startups. And I talked about a product like Perforce P4 or Git or Subversion or whatever you wanted to use. I'm assuming here I'm talking about a startup that has source control management. So you can go back and check for that video if this doesn't make any sense to you, and then loop back here. But assuming we have this centralized repository where your team is committing and is working, we can introduce CI/CD. So what's that, Gavin? You've used this term a number of times. Well, it stands for continuous integration and continuous delivery. It's the automation that turns your team's latest work into testable, shareable builds without someone having to manually stitch everything together. So integration is like you've got 3 devs, A, B, and C, and A, B, and C are working on the thing. And in the past, you have some poor sod who has to come along and go, oh, that worked, oh, it doesn't work with that, oh, you've got these, but with continuous integration, everything that is committed to the product is automatically integrated, and it's tested, it's built. And the idea with that is that if you test everything, you make sure it's constantly working. If something does come in and break, you'll know straight away. and you'll have a very small delta, which it means the difference between two versions, and you can just back out that version, or you can fix forward and you can decide what to do. But you're not in the situation where persons A, B, and C are working away in boxes, they throw all their code over the wall, and all of a sudden it doesn't work and the business has to pick itself up out of the gutter. So that's what you don't want. So here's a slightly squished version of our CI/CD diagram, because we're going to start bolting on continuous integration and continuous delivery. So when a change is pushed by any of these three people, it gets detected by the CI server. It doesn't matter what your CI server is. It might be Travis, Jenkins, Cruise Control, going back a bit with that. There are like dozens of these things. Amazon have got one. GitHub's got its own. It doesn't matter. Picks it up and then builds it. So this is what you would call compiling. So it's whatever the engineers would do locally to put the product together. So to go from whatever version that they're tinkering around with to, yeah, this is a product. So you press compile or build or whatever it is. So it's doing that on a server, which means it's not married to anyone's individual configuration. So you can then target whatever architectures you want to target. If you're building for Raspberry Pi, for example, you build onto an ARM64. If you were building for a Steam Deck, you'd build for that thing's architecture, and so on and so forth. So you can set up whatever deployment, whatever build you want. So you can have confidence that if two of the three people push code and they've tested on a Mac, and the third person pushes and they've worked on Windows, you can then make sure it's going to build for your target environment. Then it can be tested. Now, you might or might not have an automated test suite. So I'm not going to go big into automated testing here. There's a lot I could say about that. But you could run unit tests, which test small chunks of your product. You can run static analysis tools, which basically go through the code and look for common problems. It's almost like a spell checker for code. It's a little bit like that, or grammar checker. It's super, super powerful. You should always have static analysis on everything. And you can do full end-to-end tests. You can do a lot. You can put a lot in this box. Anything a computer can test, you can run here. And even a lot of stuff people can do, you can hook into that. So this is like an automatic quality assurance. So let's say you've passed all this, and I'm not going to go into super detail. I'm just trying to get across what CI/CD is. You can then go to a publish phase, which is where the continuous delivery part kicks in. So let's say your test suite's passed, you've built nicely, it builds on your target architecture, you've integrated the change from your three engineers, and you pump out a latest build. And the idea on this demo computer is that latest build will be accessible to the business so that they can test things. And what was really nice is you could automatically tell Slack every time you make a commit and it gets published. So I'm the business dude, you're the engineer, you've pushed the change, it gets built, and a few minutes later, little message pops up for me on Slack. Oh, that new feature is there. I can see all the changes, because every time someone is pushing to the source control, they're being disciplined and they're writing what they've done, and that comes through to me, and I go, right, I can go on and test this and see if it works. Now, I've got 4 outputs here, which is latest, nightly, weekly, and stable. Your model will almost certainly be different. This is just an example, right? I'm not going to go into loads of detail about this, but the latest build is just whatever commit is the most recent, that's what's running. Nightly would be, yeah, I don't know, do a build at midnight every night so you can compare back. Weekly, similar, just keep one weekly build. Say the Saturday night build is probably the most stable. And then stable would be something that you just bless and say, yeah, let's keep this one around. This nightly build, we like this. This has got the feature we want. Now, you might have more builds. You might have build for client A, build for client B, build for client C. And you know that they're going to be in a stable state because someone's not going to come along and tinker with those. So that's the difference between source code and the built artifact. The built artifact should be stable. No one should come along and change it after the fact, because it only goes from left to right on this diagram. You make your commits left to right. Yes, you do pull down stuff from the SCM, but your commits only go right, and then they go right to the CI server, and then they go right to the demo computer. And, you know, as long as you've got enough space to store them, you might as well keep them around for quite a long time. And there are different patterns for that depending on how big your artifact is. But that means that this demo computer, and let's just go for an example. Let's say you've built something in Godot, it's a game, and you want to have this running, and you can then access the demo server over your VNC or whatever remote desktop or KVM or something like that, and you can get in front of this demo computer virtually or physically, and you can test the build, and it's not going to go away or change. So if you've got a build you're happy with that's for client F, when you're in front of client F, someone hasn't tinkered with that and broken something. And the other advantage is you've got these multiple builds, so you can go, oh yeah, but here in our nightly build, look, we've got this latest new feature. It's not stable yet, but here's a preview. So you can set expectations. You can show the stable stuff and the cutting edge stuff without being at the mercy of someone's laptop being blessed. Now, obviously, this adds a lot of complexity to the technical side of your organization. You do need people who understand this stuff, who can maintain it. It's not magic. You can't just turn it on and it works. Well, depends really, but it's over the years gotten easier and easier to set this stuff up from when I started doing it 20 odd years ago in the mid 2000s with my cruise control server and my ASP and PHP stuff and early test suites. So yeah, teams do this. It works. It's an established pattern. Engineers coming in are going to be used to this kind of way of working. So I think you can see the upsides. There's other considerations that I could go into, but I'm just going to give a bit of flavor. So feature flags is something that you can toggle on and off. So you can build a feature into code that doesn't get seen until it's toggled on. So this might be something like, oh yeah, we'll turn on the new lighting engine using this flag, or we can turn it off again. So having on your demo computer the ability to flip toggles on and off is something that's a little bit, it's sort of adjacent to CI/CD, and it's a way of having stuff baked into the product but not necessarily switched on, that you can switch on when you need to. Maybe it's some client-specific code that you've decided to put into the core of the product, but to switch off for all other clients at that time. So feature flags is a way you can do that. Branching strategies, I mean, that relates to having your multiple workspaces at the end on your demo computer. So you could have like a stable branch that you merge changes into. That's one pattern. Another pattern is a stable trunk model where everything's stable all the time. This relates more to your SCM, but your SCM is deployed from, that's your source of truth for your CI/CD system. So whatever you do on your SCM, you can reflect on your CI/CD system, which then reflects on your demo machines or virtual machines or whatever they are. Don't get too hung up on the idea it's a single computer. It could be almost anything. It could be hardware, it could be cloud. But there are outputs that are stable. That's the thing to hold on to. Pre-commit checks via triggers. That's a bit of a Git thing generally, but other source control supports it. P4, for example, that Unreal people use. You can set up triggers, so you can run some very basic tests before it will even let you push commits. So even before you get to the CI/CD server, you can run commits like, oh yeah, are all the files named such that they'll work on Windows or Mac? So you can actually put these hooks in there. And unit integration and system testing, now that is very much a CI thing. This is the test box that was in the middle of our CI/CD tube. This can be a little specialist, but most developers these days can write unit tests, but it depends what you're building. If you're building a Python application, heck yes, you should have unit tests. If you're building like software, say in Unity or Unreal or whatever, maybe there are parts of that can be unit tested, your plugins and your custom code, yeah, potentially. So a suite of tests that you write can be powerful if your engineers are able to do that. If they're not, then you can think of it. You can put tests in other ways, like I've talked about. Static analysis is incredibly powerful and should be used absolutely everywhere. So I don't want to dive into all the nitty gritty. What I'm trying to do is give a flavor of CI/CD, what it is, how you can employ it. I mean, one size sort of fits almost all, I guess, the actual model. So let's go through these problems that we had. It works on my machine. Well, it runs on the demo computer. That's the source of truth. It doesn't matter if it works on your machine. We build it on our CI/CD server. We ship it to a demo machine or whatever that is, demo virtual machine, real computer, don't care. That's where the customer's going to see it. It's where the business is going to see it. So regardless of where it works on your computer, it works there, because if a build fails, it notifies the person. So it says, hey, this code that you pushed, that's got some Windows specific code here, and we're deploying to the Steam Deck, which runs on Linux. So you're going to have to fix this. So it's a good way of getting feedback fast. If you're going to fail, you fail fast, right? Load out small delta, small change set, fail on that, go and fix it, work forward. It worked last week well. We've got the nightly builds, the stable versions. We can go back. We don't have to recompile and like sweatily go through all our zips and go, oh, which zip is it? Oh, come on, compile. No, we've got them all. They're all compiled. We can just pick off the shelf. If we've got our demo set up correctly, just change the URL, change the executable we're running, whatever it is. Where did that change come from? Show me the latest version. Well, we can see the products at any time. So the business side, the creative side, and the engineering side, they're all looking at the same thing. That's your source of truth. That's your source for what the product is, not what the engineer's waving his hands. Someone like me going, oh, yeah, it works for my machine. I've done this. The deployed product that's gone through the pipeline that will work on your target architecture, that is the product. And that is what you can see. Right, this works, don't change a thing. So this kind of horrible change freeze, which is an awful thing to have. And you get it sometimes. Sometimes it's unavoidable. In big government systems, you're doing a massive rollout or something like that, and you want to freeze everything around it. Cool. But for most creative startups, you're never going to be in that position. So try to avoid it if you can, because you don't want people you're paying money to sat around picking the nails. It's not a good use of time. The developers don't have to stop because we've got these snapshots. We've got these built artifacts. We know it integrates. We know it plays nice on everyone's computer. So there is so much upside of CI/CD. So thank you very much for watching. These videos aren't usually about my areas of expertise, but I guess CI/CD is something I've been doing for 20 plus years. But I can't cover everything. But hopefully this has given you a flavor of, for a small creative startup, yes, CI/CD is something you can have. It is something you should probably set up. It's going to look different for everybody of what you're trying to accomplish, but this is the broad pattern of what it is and why you would use it. So do feel free to browse around the rest of my channel. Check out my new headshot. I got that done at the Equal Experts conference in London. I'm quite pleased with that. I look way less dishevelled than I generally look, so that's quite nice. So yeah, thanks for tuning in.